Hello, good students. It's JD here. So in this lesson, we are going to see how exactly we differentiate the tan of a certain function. So yes, we are going to look at the derivative of tan of f of x. So this is tan of f of x with respect to x. How do we differentiate tan of a certain function? So for us to find the derivative of tan of f of x, what we need to do, what exactly do we need to do? We can use differentiation using the chain rule, but there's a very straight method that you can use, which is very interesting. So what we have to do here, you need to find the derivative of f of x first. So you need to find the derivative of f of x, right? Once we have the derivative of x, then you multiply by sec squared f of x. Yes, that's how you differentiate tan of a certain function. But I also want you to bear in mind that the derivative of f of x is the same as to write as f prime of x, and sec squared f of x, you can simply write that as sec squared f of x. So yes, if you want to find the derivative of tan of f of x, what you need to do, find the derivative of f of x first, and then after that, multiply the result with sec squared f of x. This is very interesting. Let me reinforce this concept by means of an example. Let's say example 1. Here, we want to look at the derivative of, say, tan of 2x minus 5. How do we differentiate tan of 2x minus 5? The derivative of tan 2x minus 5 is equal to, like I said here, what do we need to do first? We need to find the derivative of f of x. In this case, what is our f of x? In this case, our f of x is 2x minus 5. Right, so what is the derivative of 2x minus 5? We need to find the derivative of 2x minus 5 first. And once we get that derivative of 2x minus 5, we multiply by sec squared of 2x minus 5. That's simple and straightforward. So what do we do next? What is the derivative of 2x minus 5? And for us to differentiate 2x minus 5, we basically need to use this rule. Remember, the derivative of x to the power of n is basically we bring down the power, we keep x, and then we subtract 1 from the power. So if we use this rule to differentiate 2x minus 5, we will get the right solution. For example, what is the derivative of 2x here? Straight away, you see that the derivative of 2x is basically 2 after applying this rule, right? And what is the derivative of minus 5? Remember, the derivative of a constant is 0. So here, we straight away get 0. So yes, if we differentiate 2x minus 5 using this rule, we get 2. So we multiply that result by sec squared of 2x minus 5. Yes, this is our solution. Let me reinforce this concept further by means of another example. Let's say example number 2. On this example, we want to find the derivative of what? Let's say tan, right? Tan of what? Tan of root x minus e to the power of 2x plus ln of 2x in bracket. What an interesting problem. Let us look at f of x. So is this tan of a certain function? Yes, it's tan of a certain function. And what is that function? That function is root x minus e to the power of 2x plus ln of 2x. So it's a combination of root x, a combination of an exponential function, a combination of a logarithmic function, a natural logarithmic function. So what do we have to do? The problem that we have at hand, the first thing that we have to do to find the derivative of this function, we need to find the derivative of f of x. And it's going to be a very, very interesting problem to solve. What is the derivative of f of x? So as we are finding the derivative of f of x, we need to find the derivative of each and every term within that f of x function. So we have to ask ourselves very, very fundamental questions like, okay, what is the derivative of root x? What is the derivative of minus e to the power of 2x? What is the derivative of ln of x, ln of 2x? And once we put those derivatives together, that will be the derivative of the whole function. So let's ask ourselves fundamental questions step by step. What is the derivative of root x? Remember, when you're talking about the derivative of root x, this is the same as the derivative of x to the power of half. So how do we differentiate x to the power of half? Yes, we still use this rule that I have already written up here. So we simply bring down the power and we multiply by x and we subtract 1 from the power. If we simplify this, we get 1 over 2 root x. So obviously the result, if we differentiate root x, we get 1 over 2 root x. And then the next thing, what is the derivative of minus e to the power of 2x? What is the derivative of e to the power of 2x? So remember, in another video, we have covered how we differentiate an exponential function. So if we are differentiating an exponential function, what we basically need to do, so let's say you are looking at the derivative of e to the power of f of x. Or what you need to do, find the derivative of f of x, then you multiply the result by e to the power of f of x. So here you you find the derivative of 2x, which is going to give us 2, and you multiply by e to the power of 2x. Yes, that's how we differentiate an exponential function. So if we differentiate minus e to the power of 2x, we get minus 2e to the power of 2x. Wow. What about the derivative of ln of 2x? What are we going to get if we differentiate ln of 2x? So remember, in another video, we've also covered exactly how we differentiate ln of a certain function. So for us to differentiate ln of a certain function, you need to find the derivative of f of x first, then you divide that result by f of x. So here, for us to find the derivative of ln of 2x, we need to find the derivative of 2x, which is going to give us 2. And we divide that result by 2x, and this will simplify to 1 over x. So yes, we take this result and put it here. So it's going to be plus 1 over x. Wow, this is very, very interesting. This is very, very interesting. So let's take a closer look at the results that we have at hand. It's very, very interesting. The results that we got is this one. What is this result? If we differentiate, so if we find the derivative of root x minus e to the power of 2x plus ln of 2x, straight away we get this result. Remember, I did step by step how we differentiated root x, how we differentiated e to the power of 2x, how we differentiated ln of 2x. So yes, we get this result. And what did we do after getting that result? After getting that result, we multiply this result that we have at hand with what? With sec squared what? Sec squared of that function. So with sec squared root x minus e to the power of 2x plus ln of 2x. That will be our final solution. This was a very, very interesting problem. Let's reinforce this concept further by means of another example. Then for me to reinforce the concept, let me give you a question for you guys to do as an exercise. So here is the exercise. So on this exercise, given that y is equivalent to tan of what? Tan of tan of x minus ln of 3x plus e to the power of 2x minus root x, right? So I want you to find dy dx in this case. Find dy dx. Find dy dx. This one, I'm marking it out of 5. So given that y is equivalent to tan of x minus ln, open bracket, 3x plus e to the power of 2x, close bracket. So let me just put this type of brackets here just to distinguish with the other brackets that we have inside. So let me put brackets like this here. So, and then we also have to close up here. And then let me put brackets like this. So this is tan of x minus ln, open bracket, 3x plus e to the power of 2x minus root x. So remember this function here, a function of ln of f of this natural logarithm function. So it's ln of 3x plus e to the power of 2x minus root x. This is an interesting question. Please enjoy this question. Remember what I've said, whenever you're finding the derivative of tan of f of x, or what you basically need to do, find the derivative of f of x first, and once you have the derivative of f of x, multiply by sec squared of f of x. So this method is very, very interesting, straightforward. So I want you to enjoy it as well. Awesome.